Hello. Uh, Today I will be using two decision making techniques to go over um, a decision of a laptop to be used for an engineering program to run any kind of AutoCAD. Um, the main thing noting right off the bat is that Macs aren't really an option here, so I've neglected them in the process of attributes and other things like that. So when using the SMART method, here I'm going to be using the SMART method, and I'm going to basically be making this decision based on the ratio of the cost versus the attributes and the quality of the attributes. So the decision is basically the computer that I'll be choosing amongst three of the most popular options, and the boundaries are basically the attributes that are going into this decision. So that's going to be what I'm considering are the reviews from PCMag website, the graphics card, the performance of the CPU, the battery life. Oh, this is not supposed to. Oops, sorry. This is not supposed to say performance. This is supposed to say processing power. So processing power and the graphics card performance is one. It's supposed to be one right here. Just one bullet. So the consequences or outcomes of this is obviously going to be either making the wrong decision, which won't be the end of the world, but it might affect your efficiency when you're trying to run these kind of programs and things of that nature. And a consequence, a good thing that could happen is, you get a good computer that you're really happy with. And this is an important decision because computers are very expensive, and this is big decision when it comes to doing your work and schoolwork. Is you need the right computer to run these programs so that you're not held up on things like that. So I then took the costs of the three computers I'm considering, and I wrote those down here in this chart, as well as some of the information that I sourced for my attributes. So this is all of the reviews and graphics card information for all of these things, and this is the actual data for the reviews. And then I used the internet to search all these up, and I used their respective websites. Except for the reviews, I used PCMag so that they would be kind of all from the same area and maybe lacking a bias. So then on the next slide, I'm going to basically convert these into a scale that I can judge all these by. So I basically took the processing power and I scaled it by the cores and the actual this number here. So and I did the same thing with the hours and the graphics card from my knowledge of what is best and whatnot. So I ranked all these out of 10. So here's here's that. I ranked them all except for the prices, because I figured that those were all on the same scale, so I might not need to change those. So I kept those all the same, and I changed these into ranks out of 10. So then after I did that, I calculated the weights, and I did that by essentially summing all of these. Sorry. So I gave them all a weight here. So this is what I did. I just gave them each a numerical weight that I decided. So I decided that cost was going to be 3, reviews is 2, graphics card is 1, so it's less important, battery life is 2, and processing power is 4, because I feel that that's the most important. And then I add them all up and divide each value by that to get the normalized value. Okay, we then use the normalized value that we got for the weights here, and we multiply each of these values by these weights, and we were able to come up with the numbers of which would have the highest. So in this case, the highest attribute score would be the XPS 15 laptop, which is the most expensive. So this is probably what I would choose, because I do value the processing power probably over everything else, and the price range is relatively all similar, although this is about double the lowest option, but it's also probably about double in the performance. And as we can see here, this one has the highest. So now using ATP, we're basically just going to have this set up, which our goal is to select the best laptop using our criteria, and we have the same options and the same attributes again. So now we're going to essentially set up this pair matrix where I'm saying that, so here these are all the same, but the reviews, I'm saying this is about 1/4 of importance of the cost. The graphics card is about 1/5 of important as the cost. The battery life is about 1/4 as important as the cost. And processing power is 1/2 as important as the cost. So then so on and so forth with all these. Then what I did was I added up all the sums of these, and these are here. And then with the sums, I divided each value here by the sum to get these normalized values here, which I then took the average of each row here, as you can see. Oops, sorry. I don't know if this is... Okay, so to the right of this here, you can see I have all these, the averages of the rows. And then underneath, I set the averages of the rows to the top of each, just so I can see what's going on. And I divided, so I sum all these rows here. Then taking each of these values here and putting them at the top over here. And then we're summing all of these and dividing. Oh, sorry. Well, we're summing all of these way, and then we're dividing them by these values of their respective row. So we get these as our average ratios, and then I'm going to basically just take these on the next page, these values here that I got. Oops, sorry again. I'm going to take these values that I got for these, sorry, not those values. I'm going to take these values that I got for all of these here on the top, this column here, and then multiply each of these, which I've basically translated these into a scale of 9, 0 through 9. So 1 through 9, sorry. So now with all of these, with the value that I'm getting tells me that the best option would be the ThinkPad. And this is coming because I think that I didn't set the attributes up exactly how I wanted them, and maybe the cost attributes was a little bit higher. I personally feel that a limitation of this of this method is that it's harder to basically use. It's harder to visualize the weights and how I want them to be, because there's a lot more math involved. And yeah, so even though I do think that this is close, it's not exactly what I wanted in terms of the weights, but it is pretty close. So basically, I would say that I'm able to tell that I personally feel that the SMART method is a more effective way of figuring out which to choose, because it's a lot easier to visualize and set up, and I can really see my answer and how it makes sense to me. So especially considering what I was considering to be the most important. So I really did feel that the graphics card was majorly important. I mean, not the graphics card, sorry, the processing power, as that's basically what's gonna make sure that you can run the program or not. So that was basically the most important criteria, and that really showed in this one, and that was what I wanted. So the other one, I feel a limitation is that it might be a little hard to visualize. It's a lot of playing with the numbers, but yes, basically that is all for my decisions that I've decided, even though that both of them give a different answer.